So obviously, so let's derive an expression for electric potential during isolated point charge. Correct. So this is our question. So mostly we should know some basic integration before going through this problem. That is nothing but what you should know this thing. Integral of x power n dot dx is equal to x power n plus 1 by n plus 1. So integral of x square dot dx. So we are integrating with respect to x. So this here n is equal to what? N is nothing but 2 here. So x power 2 plus 1 by 2 plus 1. So that is nothing but x power 3 by 3. So in this particular derivation, we'll encounter something like 1 by x square dot dx. Correct. If that is the case, we don't have a formula for that. But what we can do in such situation is that we can take this x square to the top. So it will become x power minus 2 dot dx. So you'll be getting x power of what? Minus 2 plus 1 by minus 2 plus 1. Using which formula? X power n plus 1 by n plus 1 formula. So we'll be getting x power minus 1 by minus 1. This can be minus 1 by x. In the sense, what I'm doing here is I'm just putting this thing down. X power minus 1, if I put it down, it will become 1 by x. X power minus 1 is equal to what? Basically 1 by x. Simple thing. Correct. So these are the prerequisite before attempting this question. So derive an expression for electric potential during isolated point charge, which means here what I'm trying to do in this particular thing is I'm trying to move a charge. I'm trying to move a charge from one point to another. From one point to another. So obviously, if I'm trying to push a chair from one point to another point, correct? Work has to be done. The chair won't move by itself. So obviously, I have to do some work. Correct. So we know a basic formula of work. What is work is equal to force into displacement. W is equal to F into D. Correct. So if here in this case, if I'm taking displacement as X and force as F, work done is what? F dot X. Correct. But again, coming to the class 12th, we will take everything as what? Very, very small units. In the sense, work also will take very small unit, because once we calculate for the small unit, right, that can be applied to all other work. In the sense, once I explain here the integration here, integration of dw, correct, or integration of dx. Here we don't have an x term, correct. So what I will put, I don't have an x term, so I will put here as what? X power 0, because anything to the power 0 is nothing but 1. Then I will apply the formula and I'll get what? This is equal to x. So similarly here also I'll get w. So instead of this w, what I can put is, I can put as integral of dw. Obviously the meaning of this is what? Integration only. Correct. So what I'm trying to do in this particular question is from infinity to r. Correct. Infinity to what? This particular point. I want to move the charge. You got the point, huh? So for that particular thing, how much work is to be done, or what is the potential? Electric potential. Electric potential is basically the work done to move a point from one point to another. That's it. So for this, what we use is we use the Coulomb's law. So we know what is the Coulomb's law. E is equal to 1 by 4 pi epsilon naught q by r square, because here we are using only a single point charge. Correct. But the most important thing, what we have to memorize here is, for the electric potential, correct, here since it is x square here, let me draw it here, the answer will be what? Just x. In the sense, 1 by, this whole thing will be same, 1 by 4 epsilon naught q by x. That's it. Okay, that will be our answer. So this always we should have our answer in our mind. So here don't worry how we got r. So if it is x square here, it will be x. If it is r square there, it will be r. That's all. Obviously here it will be what? R, because we are taking from what? Infinity to what? The point r. So that's the reason we are taking it as r. That's the reason we are getting f is equal to 1 by 4 epsilon q by r as the final answer. But again, coming to this, dw minus f dot dx, correct. So why dw in the sense, see, because why negative sign again here it is, because we are moving it against the electric field. You got the point. Work has to be done against the electric field, so that represents the minus sign. So as I told you, w is equal to integral of dw, and we are moving from what? Infinity to r. Infinity to r. So this again basically is nothing but integral of, so do not get tensed by this particular thing, infinity to r. Suppose 0 to 2 is there. This is called definite integral with the limits, correct? So coming to this, if I want to take integral 0 to 2 x dot dx, it will be what? This is x power 1. So x square by 2. Yes, and I will put the limit 0 to 2. So 1 by 2, you take it outside, correct? And here, what is my upper limit? My upper limit is 2, my lower limit is 0. So that is, instead of x, I will replace it what? Upper limit, that is 2 square, and then lower limit is 0 square. That's all. So here also we get, this is the basic thing we have to know. 1 by 2 into 4, answer is 2. But again, the answer I am not focused. I am mainly focused on the method of this. So here w is what? Infinity to r equal to minus f dot dx. In the sense, what is f? Coulomb's law, 1 by 4 pi epsilon q by x square. Correct? So similarly, while doing it, we'll take what? Except x, all are constant. I will take it outside. I will take everything outside. Clear? I will take everything outside. So I'm just erasing these things. Yeah. So I took everything outside in this. So it will be just 1 by x square. Already we have done the integration for this part. The integration for this part is what? Integral of 1 by x square minus 1 by x. We already have got it. So that's the same thing. Without steps, they are putting it here. Correct? And coming to this part, it is minus 1 by x r to, or infinity to r.